Hello everyone, Dr. MK here and welcome back to our channel. I would like to start this video with the good news, that is our channel videos have crossed 1 lakh views. Though it's a small achievement, but I would like to thank you all for your constant support and encouragement. Now let us come to the business. So in this video, I'm going to discuss Carbanion Stability multiple choice questions. I'm sure this video is going to be useful to NEET, JEE, UG-TRB, PG-TRB preparing aspirants. Shall we start? Question number 1. Correct order of stability is. So you are given 3 anions and I'm going to discuss which is most stable and which is least stable. That is, they are asking the stability order. So you need to draw this 3 anion once again. So this is an example of acetylide anion, this is vinyl anion, and this is ethyl anion. Right. Among these, you need to identify the hybridization of the carbon atoms. So this is having sp hybridization, this is sp2 hybridization, and this one is sp3 hybridization. And you need to find the s character of all the 3 hybridizations. So in this case, 50% s character, and this one has 33.33% s character, and this one has 25% S character. So you need to know the rule. I'm writing here, when S character increases, electronegativity increases. When electronegativity increases, Carbanion stability will increase. So if you apply this rule, this sp carbon is most electronegative and this is moderate electronegative and this one is least electronegative. And as I said, when electronegativity increases, the Carbanion stability will increase. So if you apply this rule, so this one will be the most stable, and second one you have vinyl anion, and least one will be ethyl anion. So the right answer is option A. Question number 2. Consider the following carbanions. You are given 3 carbanions which are coming under benzyl carbanion category, and you need to find out the correct order of stability is. Now the first species which is connected to an electron donating group, methoxy group is an electron donating group because it has lone pair of electron and it will give its electron through resonance effect. And you have second one, that is nitro group. Nitro group is an electron withdrawing group. It tends to withdraw the electron from phenyl ring. Third one, you have a benzyl anion which has no electron donating group and no electron withdrawing group. Now you need to find out which is most stable and which is least stable. I will give a rule. When electron donating group is attached to carbanion, stability decreases, whereas when electron withdrawing group is attached to a carbanion, then the stability increases. If you apply this rule, the most stable anion would be 2 and the least stable anion would be 1, and in between you have 3 because it does not have any electron donating group and electron withdrawing group. That is 2, 3, 1 is the right answer. That is option D. Question number 3. The order of stability of the following carbanions is. First carbanion is an example of primary anion. Second species is an example of secondary anion. Third species is an example of cyclopentadienyl anion. And fourth one is an example of cyclopentenyl anion. And we need to find out which is more stable, which is less stable. The species 3 is an example of aromatic species. So it has 6 electrons. So it obeys Huckel's rule, and this is an aromatic anion. Aromatic species are more stable. So this is the most stable in nature. So delocalization will be there. Apart from that, it is obeying aromaticity rule, that is 4n plus 2 equal to 6. 4n equal to 4 electron, n value will be 1, and this is aromatic, and this is the most stable anion. Next one, you have cyclopentenyl anion. So this is stabilized by resonance effect. Next one is 4. And next you have 1, because among carbanions, methyl anion is the most stable, followed by you have primary carbanion, secondary carbanion, and least stable will be tertiary carbanion. So in that aspect, that is primary carbanion, species 1 will be next stable, and the least stable would be 2, because it is a secondary carbanion. So that means 3, 4, 1, 2 is the right answer. That is option D. Question number 4. Arrange the carbanions in order of their decreasing stability. So let me draw the carbanions here. So this is an example of tertiary anion. This is known as trichloromethyl anion. So this is a secondary anion, and this is benzyl anion. And we are going to find out which is more stable, which is least stable in this case. So many people will think that is benzyl anion would be the most stable because it is stabilized by resonance effect, but that is not the case here. Let me explain here. So that is the trichloromethyl anion is the most stable in this case. Why? Because this carbon is connected to 3 chlorine atoms which are more electronegative in nature. So that means it will withdraw the electron through minus A effect. That is one reason. Second and important reason is chlorine has a vacant d orbital. So what happens here? So this anion can be stabilized by p pi d pi back bonding. So that means this anion stabilized by both minus A effect as well as back bonding effect, and this will be the most stable carbanion. Followed by you have benzyl anion, which is stabilized by only resonance effect. Next you have secondary carbanion. And the least would be tertiary carbanion. So the right answer is option C. Question number 5. Arrange the following carbanions in the decreasing order of stability. The first carbanion has no electron donating group and no electron withdrawing group. Second one has electron withdrawing group which is connected to para position. Third one has electron withdrawing group which is connected at meta position. Fourth one has electron donating group which is connected at para position. So there is only one electron donating group, so no need to look at the position of the electron donating group. Now, as I already said that when electron donating group increases, carbanion stability decreases, whereas when electron withdrawing group increases, carbanion stability increases. So if we apply this rule, 2 and 3 will be more stable. So now the question is, among 2 and 3, which is more stable? So 2 will be the most stable. Why? Let me explain the reason here. So for that purpose, I am drawing the structure once again here. This nitro group has to be drawn in this way. Now what happens in the para position nitro group? So this anion will come over here, and then this will be move over here, and this pi electron will be accepted by the nitro group. Nitro group is an electron withdrawing group. So this anion is stabilized by nitro group. Now in the second case, so this electron will come over here, and this electron will move over here, and this electron will shift at this position. It won't go to the nitro position. So this anion cannot be stabilized by nitro group through resonance effect. So minus R effect will not be taking place here, but in this case, minus I effect also will be happening. So instead of minus R effect, so minus I effect will be operating in this case. So through sigma bond, it will try to withdraw the electron, and this will be next to more stable. So the most stable will be 2, followed by you have 3. Now they apply this rule, that is electron donating group increases, carbanion stability decreases. So the least stable will be 4, and next more stable will be 1, because it has no electron donating group and no electron withdrawing group. So that means 2, 3, 1, 4 is the right answer. That is option C. Question number 6. The most stable carbanion among the following is, so this anion cannot be stabilized by resonance effect. Because between this carbanion and the phenyl group, you have an sp3 carbon. When sp3 carbon comes between a carbanion and phenyl ring or pi bond, means no resonance will be taking place. So no resonance stabilization in this compound. So this cannot be the answer. And in this case, no electron withdrawing group and no electron donating group. Now, in the fourth option, that is, it has methoxy group. You know that methoxy group is an example of electron donating group. And second one has cyano group, which is an example of electron withdrawing group. As I said in the previous slide, when electron withdrawing group increases, the carbanion stability will be increasing. And in this aspect, that is the right answer is option B. Question number 7. The order of decreasing stability of the anions. Let me draw the anions once again. First anion is an example of tertiary. Second anion is an example of primary. Third anion is an example of secondary. And fourth anion is an example of benzyl. And you need to arrange the stability order in decreasing way. You know that is benzyl anion will be the most stable, because this anion can be stabilized by resonance effect. So most stable is 4. Followed by you have primary, secondary, tertiary. I have already explained that is among primary, secondary and tertiary, primary anion will be more stable, that is 2. Followed by you have secondary carbanion, that is 3. Next, the least stable will be tertiary carbanion, that is 1. That is 4231 is the right answer, that is option C. Question number 8. Which of the following anion is the most stable? First anion is an example of cyclohexenyl anion. This can be stabilized by resonance. Second anion is an example of cyclohexadienyl anion. So this is stabilized by two resonance forms. Third case is an example of phenyl anion. In this case, there is no resonance stabilization. And fourth case is an example of cyclopentadienyl anion. So this is resonance stabilized. Apart from that, it is stabilized by aromaticity. So in all the four cases, that is the species D, that is cyclopentadienyl anion, is the most stable because this is an 6 pi electron species. So this is aromatic in nature and this will be the most stable. Question number 9. The least stable carbanion among the following is. First case is an example of benzyl anion. This can be stabilized by resonance effect. Second case is an example of trichloromethyl anion. This can be stabilized by p pi d pi back bonding. I have explained just before. Third case is an example of like a crotonaldehyde derived carbanion. So this can be stabilized by resonance effect. And the fourth case is an example of phenyl anion. So in this case, there is no resonance stabilization. So the question is, that is the least stable carbanion. So in this case, that is D is the right answer. And the last question is, which of the following species is not resonance stabilized? The first species is an example of lactone. So this oxygen lone pair will come over here and this electron will move towards oxygen atom, and as a result you will get this resonance form. So this is resonance stabilized. Second case is an example of cyclohexanone derived carbanion. So this can be stabilized by resonance effect. As a result, you will get this resonance stabilized form. In third case, that is D. So this can be stabilized by resonance effect because this is an example of an allyl anion. And that is the fourth one, that is C. If it undergoes resonance, it will result this resonance form. And if you happen to look at this form, this is unstable. Why? Because it is violating the Brett's rule. So when Brett's rule says, that is when a species having double bond at bridgehead position, this will be unstable. If it is a larger ring system, means that type of species are more stable, but this is a 6-member ring. So in this case, the bridgehead position has a double bond, so this is unstable. So this will not form. If it is not forming, means this kind of resonance stabilization will not occur. So the question is, which of the following species is not resonance stabilized? The right answer is option C. That's all. So I'm sure this video is going to be very much useful to you. And if you find so, you can like the video, share your opinion in the comment section, and do not forget to subscribe our channel. I will meet you all in the next interesting topic. Until then, take care. Bye. ஸோ என்னோட ப்ரீவியஸ் வீடியோவை நீங்கள் பார்த்துருப்பீங்க. தட் இஸ் PG-TRB, Polytechnic-TRB, IIT JEE அண்ட் SLET எக்ஸாமினேஷனுக்கான ஆர்கானிக் கெமிஸ்ட்ரி ஆன்லைன் கோச்சிங் ப்ரோக்ராம் ஆனது நெக்ஸ்ட் வீக் ஸ்டார்ட் ஆகுது. ஸோ உங்களுக்கு இதில் ஜாயின் பண்ணணும் அப்படின்னு விருப்பம் இருந்ததுன்னா என்னோட நம்பர் இங்கே கொடுக்குறேன். ஸோ இந்த நம்பருக்கு நீங்கள் வாட்ஸ்அப் பண்ணுங்கள். ஸோ தட் நான் உங்களுக்கு எவ்வளோ சீக்கிரமாக கால் பண்ணி ரெஸ்பாண்ட் பண்ண முடியுமோ பண்ணுறேன்.